Greetings, math fans. Alright, so this is day 2, and what we're going to be doing is we're going to be using some of our identities and simplifying as much as possible. Now this is all really kind of the last day we're actually going to be simplifying without much guidance. Okay, so you're going to basically be turning things into, let me just kind of write a couple things out here. The one you're going to do sine and cosine, and really the second kind of main thing here is we're going to eliminate fractions. Okay, so we really don't want any fractions in our final answer. Okay, that's kind of just like two main rules here. And like I said, today's the last day where there's no guidance, where tomorrow I'm going to say, well, now you got to prove one side is equal to the other side. So you have something to work on, something to, basically a goal. So let's start off here. First one, again, if you don't see anything else to do, sines and cosines. So tangent is sine of theta over cosine of theta times cosine of theta over 1. So that's equal to sine of theta. Pretty easy. Next one, obviously what do? We're going to FOIL. So we're going to do 1 plus sine of theta minus sine of theta minus sine squared of theta. Well, these cancel and we get 1 minus sine squared of theta. And just remember, look back at your old notes, math fans, what we learned yesterday, the Pythagorean identities. Right? For example, this one is sine squared of theta plus cosine squared of theta equals 1. And so if you see a 1 and some trig function that's squared, look to see if you can write that combination of 1 and that trig function with just another simple trig function, right? Okay, because for example, 1 minus sine squared, I can subtract sine squared from both sides, and that equals cosine squared of theta. So that's your answer for that problem. Okay, number 3. Again, sines and cosines. So sine of theta times 1 over cosine of theta. That's sine of theta over cosine of theta, which equals tangent of theta. Okay, this next one, we have an identity on top right away. 1 minus cosine squared is sine squared of theta. And 1 plus tangent is another identity. That's going to be secant squared of theta. Okay, no fractions. So again, what we're going to do is sines and cosines. So of course this is already sine squared, and this is 1 over cosine squared of theta. And so you can write this as sine squared of theta times the reciprocal, so times cosine squared of theta over 1. And then your answer is just sine squared of theta cosine squared of theta. Okay? Number 5, same idea. 1 plus cotangent squared of theta is cosecant squared of theta. 1 minus cosine squared is sine squared of theta. Okay, so let's write it out. 1 over sine squared of theta over sine squared of theta. Now it's really, really tempting to say, oh, that's equal to 1, but it's not. It's 1 over sine squared of theta times, right, the reciprocal, so 1 over sine squared of theta. That's 1 over sine to the 4th of theta. And the reciprocal function is just going to be cosecant square, or to the 4th of theta. That's the answer to that problem. Okay, the next one, we recognize that one, causes pause, so it's cosine of theta over cosine squared theta. Well, that cancels that one out. It's 1 over cosine of theta, which is secant of theta. Okay, number 7. Actually, we did this one yesterday. You guys should really recognize this one, right? Isn't that 1 plus cotangent squared of theta? And that's going to be equal to cosecant squared of theta. Okay, this one, it's, what do you do? It looks kind of complicated here. You could, if you look at that, now some of you might say, look at this 1 minus tangent of theta. You might look at this and say, oh, well, we can probably do something with that. But guys, you need to be careful. It's not 1 minus tangent squared of theta. It's 1 minus tangent theta. Actually, even if it was 1 minus tangent squared, you couldn't do anything, and the only reason is because it needs to be tangent squared of theta plus 1. But anyway, what I'm going to do is I'm going to FOIL that out, and write it twice and FOIL it out. So I get 1 minus 2 tangent of theta plus tangent squared of theta minus secant squared of theta all over sine of theta. Well, now I have that 1 plus tangent squared of theta. Okay, so I can write that as secant squared of theta minus 2 tangent of theta minus secant squared of theta over sine of theta. Well, the secant squareds cancel out, and we have negative 2 tangent of theta over sine of theta. Again, no fractions, so write in terms of sines and cosines. Negative 2 sine of theta over cosine of theta. And guys, don't make the mistake of writing the negative 2 on the top and the bottom, because it's tangent, right? It only belongs on the top. And then that's that's over sine of theta over 1. So I can write that. I'm just going to write over here, math fans. So it's negative 2 sine of theta over cosine theta times reciprocal. So times 1 over sine of theta. So sine of theta cancel out, and we get negative 2 over cosine of theta. And of course, then 1 over cosine of theta is secant. So it's negative 2 secant of theta. All right. Okay, let's keep going here. Number 9. Now, this one's a little tricky, and what you want to do is we basically, in order to combine these together, you need to multiply by something to get a common denominator. Okay, so what I'm going to do is I'm going to multiply this side. I'm running out of room here on this side, but 1 plus cosecant of theta over 1 plus cosecant of theta, and this by 1 minus cosecant of theta over 1 minus cosecant of theta. So if I do that, I get 1 plus cosecant of theta minus, now you got to be careful, math fans, it's minus that whole thing, so it's minus 1 plus cosecant of theta. Okay, and on the bottom you're going to get 1 minus cosecant squared of theta, right? The inside and the outside cancel, and you're left with the first and the last. Alright, so this is the deal. The ones are going to cancel, and you're going to get 2 cosecant of theta. And on the bottom, well, isn't this, let's just write this out, isn't this cotangent squared of theta plus 1 equals cosecant squared of theta? So if I say 1 minus that, if I move this over here and I move this over to the other side, it's equal to negative cotangent squared of theta. Okay, so you got to watch your signs, math fans. Okay, then I'm going to write in terms of sines and cosines. So this is 2 over sine of theta divided by negative cosine squared of theta over sine squared of theta. Okay, so just, no big deal. 2 over sine of theta times the reciprocal. Negative sine squared of theta over cosine squared of theta. So that cancels with that, and I wind up with just negative 2 sine of theta over cosine squared of theta. Now, this is the deal, math fans, is really it's negative 2 sine of theta over cosine theta. So these guys right here, I can just take one of them. It's negative 2 sine over cosine is tangent, and 1 over cosine is secant. So that is actually our final answer. Okay, it's negative 2 tangent of theta, secant of theta. Alright, the next one is to simplify that until it looks like negative tangent theta sine theta. So obviously we're going to FOIL, and it's going to be 1, this is kind of what I'm going to be talking about tomorrow. Alright, so it's 1 plus cosine theta minus secant of theta minus secant theta cosine of theta. So 1 plus cosine theta minus secant theta minus 1 over cosine theta times cosine of theta. That cancels. And so I get 1 minus 1, which is 0, and I wind up with just cosine of theta minus secant of theta. Well, I still need to get it to look like that, and sines and cosines. So cosine of theta minus 1 over cosine of theta. And then, of course, we're going to get a common denominator, so I'm going to multiply this by cosine of theta over cosine of theta. So I get cosine squared of theta over cosine. Actually, let me put the whole thing. Right, it's cosine squared of theta minus 1 over cosine of theta. And, let's kind of write it up here. Sine squared of theta plus cosine squared of theta equals 1. Okay, so that's just going to give us sine squared of theta over cosine of theta. And similar to the other one, if I have sine of theta over cosine, it's negative, right? So it's negative up here. So I have one of these is negative tangent of theta, and this other one is just going to be sine of theta. And of course, that is the same as that. Okay? All right, let's keep going here. Again, it should delete this so you can have more place to write. So number 11, there are a couple ways you can do that. You can write it in terms of sines and cosines, or you can just get a common denominator. It's sometimes you don't know, and sometimes you just try one or try another. I'm actually going to, let's multiply this by tangent of theta over tangent of theta to get a common denominator. So that gives me tangent squared of theta plus 1 over tangent of theta. Ah, there we go. Tangent squared of theta plus 1 is secant squared of theta over tangent of theta. Okay, so then we write it in terms of sines and cosines. We get 1 over cosine squared of theta over sine of theta over cosine theta. That's equal to 1 over cosine squared of theta times cosine of theta over sine of theta. One of those cancels with that, and I wind up getting 1 over cosine theta sine theta, which is just secant of theta cosecant of theta. Okay, and give them a little more room here. All right, so with number 12, I could just get a common denominator right away, but you don't really want to mix sines and tangents together. You can mix sines and cosines and tangents and secants together and cotangents and cosecants, but it doesn't really do good to mix other stuff together because it's not going to really do anything for you. So I think what I would do right away is I would change this to sine of theta over cosine of theta plus cosine of theta over 1 plus sine of theta. Okay, and then now let's get a common denominator. I'm going to multiply this one by 1 plus sine of theta, and this by cosine of theta. So on top I get sine of theta plus sine squared of theta plus cosine squared of theta. Oh, that's kind of nice. And at the bottom I get cosine of theta, 1 plus sine of theta. So of course sine squared plus cosine squared equals 1. So I get 1 plus sine of theta on top, and cosine theta 1 plus sine of theta. The 1 plus sine of theta are gone, and we have 1 over cosine of theta, which is just secant of theta. Alright, it's not too bad. Okay, so the last part real quickly is just to kind of recall some information here that you guys learned back in Algebra 2. A difference of two squares, difference of two cubes, sum of two cubes, and a perfect square trinomial. Alright, so this is like number 13 is just like factoring 1 minus x squared. It's 1 plus x, 1 minus x. And so that's when I'm going to write it here. It's going to be 1 minus tangent of theta and 1 plus tangent of theta. Okay, this next one is actually a difference of two squares. And I don't know how you guys learned it back in the day, but the square root of 4 is 2. The square root of 1 plus sine of theta quantity squared is 1 plus sine of theta. So that's kind of how you come up with your numbers in here. So we're going to say 2 plus 1 plus sine of theta and 2 minus parentheses 1 plus sine of theta. Okay, so if I simplify it, I get 2 plus 1 is 3 plus sine of theta. And that's 2 minus 1, right? You distribute the negative. So 2 minus 1 is 1. And then minus sine of theta. Okay, that's that factored. And this one is a perfect square trinomial. So this is going to be factored as 2 sine of theta plus 1. Or this is minus 1 here, sorry. And 2 sine of theta minus 1. So the answer is 2 sine of theta minus 1 squared. Alright, so this next one, just think of it as 3x squared minus x minus 2. So if I factor that, I would get 3x and x. And then I would get plus 2 and minus 1. And that would give me the correct middle term. So really, we just with cosine, so it's 3 cosine of theta plus 2 and cosine of theta minus 1. That's the answer to that one. Alright, and the last one is a sum of two cubes. So you take the square root of 1, which is 1, square root of tangent cubed is tangent of theta, and then you just kind of plug it into that equation. Right, it's 1 plus tangent of theta, and then it's going to be 1 minus AB, so minus tangent of theta, and then plus b squared, so plus tangent squared of theta, and that's that number factored. Alright, so that's again just kind of showing you guys a little bit about identities, and now basically then tomorrow is going to be just dealing with you're going to know what the right side and the left side are, and you're just going to have to prove that they're equal to each other. It's a lot more mellow tomorrow, though still some tough problems. All right, that's it, math fans. Have a great day. Adios. Goodbye.